what is the most common death of AGVs and AMRs? It is actually collisions with manual vehicles like forklifts and milk runs. And that's why we're gonna dedicate this episode to discuss on how mobile robots and manual fleets should and could collaborate with each other.
Automation Awakenings, your weekly dose of best practices for logistics automation.
Welcome back to another episode of the Automation Awakenings podcast. As always, with Oliver Zuchowski and myself. And in today's episode, we're going to touch upon a really important topic, not only today, but even more so in the future. Right, Olli?
Yes, absolutely. So we are talking a lot about automation, but still we have not arrived at a fully automated logistics, right?
Exactly. And the big question that we should answer first is where we will still have those touch points between mobile robot fleets and classic manual fleets like forklifts, like milk runs, that will still be driven by humans, actually.
Yes, I think we have a common dream. There are different words for it,
I
right?
had a dream.
Yeah, I have a dream. I have a dream of a dark logistics
Yeah.
or black logistics.
Mm-hmm.
So there are different words for it, but all mean the same. I have one common target, having a fully automated warehouse, fully automated processes throughout basically the whole life cycle in your plant and even beyond, maybe.
Yeah.
Yeah. This is our common dream. We are working towards that, but still we are now in coming to a transformation phase or in the middle of a transformation phase where many processes can be automated, are already automated,
Yeah.
and still for certain process steps the human is still much better than the robot.
Exactly. And this is processes like loading and unloading of trucks. These are processes like, some of the warehouse operations in a high rack, you can say, yard operations. And if you want to learn more, actually go back to our episode on no-go use cases,
Right.
because this is exactly where humans are still better and will be so in the next 2 to 5 years, right, Oli?
Yes, I think we need to talk about two categories of processes. One category is you just cannot automate it with current automation tech.
Yeah.
Others you probably can, but they are still much slower, less efficient than the human.
Yeah.
So we are now reaching a point where basically everything is possible with technology, but
It doesn't pay off.
it doesn't pay off. So there's no business case, and it's just very slow. And I cannot imagine a truck driver waiting for hours because you have a cool AGV in your plant, unloading it.
Exactly. So, and this is why we see everywhere we go and automate still these kind of interactions between manual fleets and mobile robots. Could be handover points, could be sharing the same aisles, the same driveways, could be sharing the same sources and destinations. So basically everywhere where these different devices are operated at the same time. And this comes with a set of real problems sometimes.
Oh yeah.
Because, well, mobile robots are sometimes very small, for example, so you wouldn't see them really good. If you are a human forklift driver, and you are tired, and maybe it's a little bit dark, and you then eventually even run into the mobile robots. And I've seen really crazy pictures from some of our customers where basically forklift forks would
Oh no.
would part or would crack the AGV in two parts because the driver just simply ran into the AGV that was around the corner. And you see those accidents time and again. And that's why it's really important to talk about this aspect, because it's a safety aspect. Thank God I haven't yet heard about a human being damaged during such a collision, but it's of course very costly because the mobile robot will be totally destroyed and you will have to replace it. So yeah, let's put our heads together here, Oli, and let's think about options on how to get these situations handled, and maybe also to provide a little bit of an outlook what needs to happen to provide like a solid foundation to run an ecosystem that consists of mobile robots and manual vehicles.
Yes, absolutely. Maybe to give a little bit of background, why this actually happens and how is that possible, and why AGVs are not crashing into each other. Usually, that are really rare cases. AGVs and AMRs have safety sensors. They have a safety zone, which is always active.
Yeah.
So if you are in close to a collision, they would just stop. Even if they don't see each other, they don't know each other,
Yeah.
they will detect each other as a moving obstacle, they would stop. They would also stop for a manual forklift, of course.
Yeah.
On the other hand, the human has the full power, the full control of the device. There are no further sensors, no safety zones, etc.
Exactly.
If he pushes, if he accelerates, and he goes just towards or into the AGV, right? Nothing will stop him.
Into the AGV or into a high rack.
Yeah, happens as well.
Have you seen those videos on, I
Oh
think, YouTube
God,
or something, or Instagram?
it's a disaster.
Like
Like
these shorts when
the whole
they run-
high rack collapses.
Exactly. They run to the one, rack, and then it collapses, and then the next one collapses, like a
Oh God,
domino effect.
he's destroying the whole warehouse.
Really bad.
This will not happen with an AGV.
No, it wouldn't
Also
happen.
with a high rack reach truck AGV. I mean, could be a technical failure, yes, but then it will stop. Yeah, but the human has full power, full control,
Yeah.
and disasters occur.
Yeah. They're actually even calculated in. But of course, safety must be the highest priority, whatever you do, because human life is priceless, obviously. Also, a human health is costly or priceless. So, how to avoid these situations, Oli?
Yes.
Maybe let's start with the hardware side, and then I add my software view on that topic.
Yes. I mean, the big topic is making them visible. On both hardware and software side. On hardware side, especially for small devices, and very tricky are underrider, because they are like a skateboard
Yeah.
on your shop floor, and if they have no load on top, how can you see them?
Yeah.
And we still not having good solutions for this kind of situation. If you are on a forklift and you're looking towards you, you might just not see this underrider. So for other devices, like for dolly movers, there are attachments, like little antennas.
Like
I've
those
seen
flags or something, right?
some flags, tennis balls, lights, special flashing lights, and so on. There are, let's say, attachment to make it higher, to make it visible.
Like accessory. You can say.
Accessory, exactly. You can buy it in addition. This helps already. For underwriter, we don't have such a thing. I never seen it. I mean, some of them have a blue light, but also think about that the blue light of an underwriter will not reach pretty far because it's
Yeah.
on such a low position.
Yeah.
Also dangerous. So on the hardware side, we come quickly to a limit what we can do to make them visible. But I know that you have some interesting solutions on software side, right?
I wish it was only me. I wouldn't sit here now. I would be driving around in my McLaren. Um, no, I mean, to put the jokes aside, on a software side, of course, there is also a lot of investigation into this problem because obviously it is a challenge that needs to be tackled. And back in episode 23, we talked about software required for mobile robots. And in this episode, I talked a lot about agnostic fleet managers, which is a very complicated word, but doesn't say, or which actually only says that there is some kind of master control, master brain fleet management software that is controlling individual mobile robots using, for example, the VDA 5050 standard. And now the discussions and also already first products go into the direction to open up this agnostic fleet manager to also add manual operated vehicles as actors into the fleet management capabilities of this tool to basically provide visibility, not where the AGVs are, but to provide visibility where the human-driven vehicles are, to be able to stop the mobile robot before a crash. Not the human. You won't be able to control the human, as you said. He might have a bad day, he might be tired, he might have a cold, whatever, and he's just simply gonna do mistakes. That's the way it is. Plus, he doesn't have those safety sensors. But what you can do is to basically stop the AGV before it's too late. But to do this, as I said, you will need to see in real time where your manual vehicles are moving. And this new type of agnostic fleet management is basically called Intralogistics Operating System because it doesn't include only mobile robots now. It includes all other actors that are moving around on the shop floor. So forklifts, milk runs, I don't know, some even also include humans. Other devices that we have, this like pump tracks, how do you call them?
Yeah. The Ameise.
The Ameise, the so-called.
Yeah.
Yeah, the whatever, like the manual fork that you can use to basically lift pallets and to manually move them from A to B. So even it even goes that far to even track these devices. What you need to understand is that you also require additional technology to do so. Because obviously these vehicles today are not feedbacking their real-time position to any system.
Sure.
So what you need is to put some kind of tracking system on top. Could be ultra-wideband solutions, could be like scanner solutions sitting on top or being mounted on top of the vehicles that are scanning the environment the whole time and then send back the location information to the Intralogistics Operating System. So there's different aspects that could enable this situation or this function, but they're still quite costly because, of course, you have to equip all of your manual vehicles with this technology, and you need to also have the location ID of these manual vehicles being processed and delivered in a way that your Intralogistics Operating System can use it to do traffic management.
Okay, interesting. So that means I need to do a lot of retrofitting, or is it possible to buy forklifts that are already equipped with such technology?
As far as I know, these are mostly retrofit
Mm-hmm.
solutions. I've never heard uh, about a forklift or a manual vehicle that is already having this as a default function. Maybe it's possible. So guys, if you know such a solution, let us know. But I have never encountered something like that.
So it seems to be a gap in our current landscape because, as we discussed, this transition period of having manual and automated vehicles together,
Yeah,
working together, will be long, probably.
yeah. What is your guess? How long will we still have the interaction or the touch points?
Yeah, of course, this is a difficult question, but I'm pretty sure that at least till 2030,
Mm,
35, there will be human operators on the shop floor. This I can tell you for sure.
okay.
Yeah, what happens later on is really difficult to predict,
Mm,
but I'm not seeing an automated truck unloading in the next 5 years,
mm,
for example.
yeah, yeah. And as a little spoiler, I think this is going to be our next episode. Where we're going to open up a little bit on our thoughts whether humans will be completely replaced by robots and other machines in logistics in the future, or whether there's still going to be use cases, still going to be also needs to keep humans as part of the intralogistics ecosystem, so to say.
Yeah, exactly.
All right, but let's put this aside for the moment and let's get back to today's topic, the interaction of mobile robots with manual driven vehicles. And we talked about a bunch of hardware options that we have, which mainly go towards buying additional accessories to improve the visibility of mobile robots. And then, secondly, we also talked about software solutions that are evolving at the moment, going towards the Intralogistics Operating System that is also capable of processing real time location data of manual driven vehicles to basically protect to protect mobile robots from manual driven vehicles by stopping them in case there is a risk of a collision.
Very true. And I would like to emphasize the importance of this intralogistics operating system also for being ready for other technologies to come, which we
Mm,
maybe don't know yet. I have one example at least. Yeah, there are more and more things which are being automated, right?
yeah.
And one, let's say, yeah, currently discussed topic is the automation of cleaning devices.
Oh, yeah.
Cleaning robots.
Mm-hmm.
I mean, we have these vacuum cleaner robots at home. There are now more and more suppliers also for cleaning shop floors, so industrial style devices.
Mm.
It's another player, another device
Yeah.
on your shop
Yeah.
floor,
Yeah.
which needs to interact with your automated devices and your manual devices as well, because sometimes they clean also during the shift.
Yeah.
For
Right.
example,
Right.
the next topic, camera technology, um, scanning barcodes, labels,
Mm.
big topic in logistics. Imagine to have camera gates in the goods receipt area. Imagine having or using cameras at built in a AGV, for example.
Mm.
yeah, then the very famous example of drones, which are discussed here and there. Who knows? Maybe sometime they will get more interesting for our warehouse.
Yeah.
You need a system which, makes this orchestrates all these devices.
Yeah, that's the nice word to describe it. Yeah, orchestrate all of it, and basically manage the traffic that is going to arise. Manage the traffic in a way that it's safe for each and every of these actors to build a sustainable use case out of it. Because I can guarantee one thing: the moment safety becomes an issue, the whole thing will be shut down. It will, 100%. At least in Germany, but I believe in many other countries as well.
Yes, so I think this is a good conclusion of our episode today. There are many players in logistics automation. The human is a crucial part of it and will be a crucial part of it for a long time. We'll have a long time of a transition period, a hybrid situations, and the complexity will just increase with more players, more devices, different types of technology. So fasten your seatbelt, Matthias.
I always wear a helmet.
Yes, yeah, that's
But
better.
the seatbelt is also good. Will do. And that's also great for us, for Automation Awakenings, because obviously we will continue to produce content for you guys to make sure you are up to date. And fresh content, great content will follow already next week on Monday. So we hope to see you again. Have a great rest of the day. See you soon, and goodbye.
Goodbye.
This was another episode of the Automation Awakenings podcast. Visit us at automation-awakenings.com.